comes in this way, right? And then you have a screen ahead, and this is bright. But then let's say that's the first dark. M equals 1, first dark. Notice that this is kind of nice. Remember that for the double slit, right? The first dark corresponded to an M equals 0. And the second dark was M equals 1. Here, in this case, well, you don't have M equals 0, but then the first dark goes with M equals 1. So there's something to notice. And then you have bright, and then you have the second dark, right? So if I go from here to the first dark, this is theta 1, right? And we had the condition that for the dark spots, A sine theta is M lambda. Well, if M equals 1, then this becomes A sine theta 1 equals 1 times lambda. Right? So the sine of theta 1 equals lambda over A. Well, what if, which is usually the case, theta 1 is small? Well, you say, there are two things you can say. One is that the sine of theta 1 is approximately equal to the tangent of theta 1. Or the sine of theta 1 is approximately equal to theta 1. And this is just from the Taylor series expansion of, because this is minus theta 1 cubed over 3 factorial plus theta 1 to the 5th over 5 factorial, right? But if theta is very small, this is cubed, this is raised to the 5th power, so it's just theta 1, right? So I can write this expression as theta 1 is lambda, or approximately lambda over A. So that would be this one. This is roughly just the wavelength divided by the wavelength of the light divided by this width. So I guess you can say, if I ask you, what is the minimum angle that's going to give you a dark spot? Well, it's just this. Okay? Well, the minimum angle is the one that's the one that will correspond to M equals 1. So that angle will be, if I just use this, with M equals 1, I get this, and then the sine of theta is approximately equal to theta because it's small, then it's roughly that, right? So that's that comment that I have in my notes over there. Now, what happens in the case of the circular slit? Okay. So we have the single slit of width A, right? That's what we have over here. And for this first dark spot over here, we can say that the sine of theta 1 equals lambda over A. If I consider the second dark spot, we don't use a different color, so it stands out. So then I have theta 2. So for that one, I'll just get this expression with M equals 2. So it would be, the sine of theta 2 will be 2 lambda over A. So the sine of theta 2 is twice lambda over A. And if I draw a third one, bright, dark, which would be m equals 3, then this is the third dark, right? Then in that case, we can say that the sine of theta 3 equals 3 lambda over A, correct? Where theta 3 is this. All of that. So, and over here, we had that for the single slit, the governing equation is that A sine theta, and I'll just say for dark spots, right, is equal to m lambda, right? That's how I got this quantities over here. I think I can erase this now. Okay, what if we have a circular aperture? Do we specify the radius or the diameter? Let me. Usually the diameter. Yes. Of diameter d. Which of course is twice the radius, right? So it's a circle, right? Of diameter d, capital D. So in that case you have, I'll try to draw it like that. You have light coming in, right? A certain wavelength lambda, right? And then the diameter is d. But if you look straight ahead at the aperture, notice that the difference between this slit is that if I look straight ahead at the slit, the width of the slit, right, is the same throughout the slit. In the case of the circular aperture, if I look straight ahead at it, right, this is the aperture. The diameter is this in the center. But as I move up and down, the width is not the same. It's changing. So, you know, these equations have to be adjusted to take into account the fact that the width of the slit is not the same throughout, right? Because it's not a slit anymore, it's a circular aperture. So you have this screen over here, right? And then you get a bright. Like before, you get a dark, and then you get a bright, and then you get a dark, and you get a bright. And then I like to put another dark one if possible, right? So what happens is this. If you go to the first dark, so this is the first dark, and you go like this, that's theta 1. Then the answer is that the, what is it? What's the answer? The sine theta is 1.22 lambda. So it's, I don't think I have it written down. So it's, you get that the diameter, which now plays the role of A over here. This is the width, same width. Sine theta is equal to 1.22 lambda. So in other words, this first equation becomes like sine of theta 1 for the first dark, right? Is instead of lambda over the width of the slit, it's lambda over the width of the slit at the center, which is the diameter, but then you have a correction of a factor of 1.22 instead of 1. So here you have a 1. Over there you have a 1.22. If you look at the next one, the next dark, which I used over here as blue, so that's this one, this is the and dark, then you get that the sine of that angle is lambda over d. So instead of having 2 lambda over the width, it's another number, which I don't remember. Does anyone have the book? It's in there, or maybe I should go get it. Someone pull up the textbook? Maybe I should go get it, because I'll know where to look. I'll be right back.